after knowing the composition of the functions, we will be moving on now with the next lesson, and that is the inverse function. Okay? Inverse function. Meaning, when we say inverse function, this pertains to the kind of function that project, or shall we say, give to you the one-to-one correspondence. So, in the one-to-one correspondence, meaning to say, if we are going to illustrate this one, if I have domain and range, they have elements. What are the elements? Shall we say the elements of this one are this number. Number 1, 3, 5, 7, 9, and so on and so forth. So, I have also in here that is even number 2, 4, 6, 8, and so on and so forth. Now, I have in here a representation of function wherein there is a one-to-one correspondence, meaning to say one-to-one pairing. Okay? One-to-one pairing. Notice that at one point, when we define a function, we have said that a function is with an element in the domain that are not repeated. Meaning to say the domains are not repeated, so that the function or the relation can be said to be a function. Meaning, with regards to the range, it is allowed that the element can be repeated. And so, still that is a function. So that when we say inverse function, this is a special type of function that will only tell to you that when we say inverse function, there must be a one-to-one correspondence, one-to-one pairing. Another one is, there must be the uniqueness of the range. Why unique? Because the range, the element in here, or the values of x in here, are not repeated. Now, if we say this is considered to be our original function, now what must be its inverse? The inverse of this one, the domain and the range, okay, is actually the reverse of the original function. Meaning to say, when we are going to get the inverse of this function, okay, represented by this table, meaning the reverse of these elements that we have are considered now to be its inverse. How is that? The member of the domain will already be the members of the range. Okay? So, meaning, if I have in here, in the original function, you mark this one to be an original function. If I have in here the inverse, my domain would be 2, 4, 6, 8. Okay? 2, 4, 6, 8. What about in here? This must be 1, 3, 5, and 7. So, meaning, if we have the original function, shall we say, these are our function, okay, represented by f of x, the inverse of this one, the inverse of this one would be f of raised to negative 1 of x. Okay? So, if you see this symbol, this pertains to the inverse. So, when we talk of inverse function, there is always the source of that inverse function. Now again, when we say inverse function, this is denoted by the negative 1 as the exponent. When we say inverse, it is the opposite. Okay? Now what is the opposite of the domain? The range. And so, if we are going to have also the range, what is the opposite of the range? The domain. And that is seen in the inverse. You can see that one below. Notice that when we are going to illustrate, we can also make use of this illustration, set of points, okay, or set of coordinates. Shall we say we have, okay, we have in here 1, 2, another point 2, 3, another point 3, 4. Another point we have in here 4 and 5. 4 and 5. That is the set of our function. Shall we say the original function? Now what must be its inverse? We just reverse, interchange. So what would be the inverse? Okay? Inverse of that one. Okay? So we say the inverse must be, okay, just the same with this. That is the same as 2 and 1. Another 3 and 2. Another 4 and 3. Another 5 and 4. So that must be the inverse of the sets of points. Okay? We just interchange the value of x and y. Let's go back. When we say inverse function, again, it expands or it expounds one-to-one function. When we say one-to-one function, this can be illustrated by this example. Our example in here is the set of domains, the set of range. You notice that there must be the pairing of numbers, and they are called to be coordinates. Notice that in exactly one element of the domain, it is paired with exactly element of the range. 3 is exactly paired with 4. 5 is paired with 6. 7 is paired with 8. Now, notice that the element of the domain are not repeated, so that it can be said to be a function. And another one, the range in here are not also repeated. So, unique. Now, if this is an original function, shall we say f of x, what would be its inverse? It will follow that the properties in here can be seen in the inverse. Meaning to say, there is also one-to-one correspondence. One-to-one correspondence. The domain also, the domains are not repeated. The ranges are not repeated. Do you follow? They are not repeated. Another one, when we say this illustration is the inverse of this illustration, notice that the element in the domain are the element of the range in the original function. Another one is, in the inverse function, the element of the domain, the elements of the domain, the range, I should say, the element of the range are the element of the domain in the original function. Now let's try to look into the other example. Okay, we have in here set notations. Okay, the set of points 1, 2, 3, 2, 3, 3, 4, 4, 5. Now how do we get its domain? You just interchange. We have in here 2, 1, which is the same as from in here being interchanged. We have in here 3, 2, which is coming from the original function 2, 3. We just reverse them. Whereas 4 and 3, we just reverse the original point of the original function. That is the same as in here. Another one is, that can also be seen in another sample if we have a table. Table, shall we say table for x and y. We have in here the original function, shall we say we have 5, 10, 15, 20. Okay? Now, another one in here is -5, negative 10, negative 15, negative 20. The question in here is, what must be its inverse? What are the inverse of this one, of these points or coordinates? Meaning, it will follow the interchanging of the values of the domain and the range, or the x and y. So that is the same as, if we are going to get its inverse, we say negative 5, 5, negative 10, 10, negative 15, 15, negative 20, 20. See? It's very easy to get the inverse. So again, it is our f of x. What is the inverse? That is the same as f raised to negative 1 of x. If this is our original function, we say this is g of x. What must be this one? G raised to negative 1 of x. To tell you that that must be the inverse. Again, the inverse function has its source. It came from original function. Okay, copy this one. One of our focus in the inverse function is to find the inverse of a given function. If the points, the pair, or the coordinates are given, you just interchange. Now, what about if you are given a function? Okay, so we have in here, you have the notation that is the same as we have in here, g of f of x, but you notice they are both equated to x. Meaning to say, will they be equal when they are both equated to what is that? To x. Now let's try to see. The same as 2x plus 3. Before we're going to have this one, try muna tayo dito. Now, how do we get the inverse? How do we get the inverse of this one? We follow these steps. Meaning, replace yung f of x with y. Another interchange after replacing the value of x, f of x and y, you interchange. Interchange the position of x and y. And of course, if you have already interchanged the position of x and y, there will be what we will now new y. And that's the time you compute now for the value of this one. Okay, compute now for the value of this one. Now let's try to look into this one. Okay, let's try to solve it. So it says in here in the step number 1, we change this f of x to what? Y. So that is the same as y is equal to 2x plus 3. Remember, I told you last time that what? F of x is the same as? The same as y. When we had the introduction of function, I told you that f of x is the same as y, so we can change them. Diba, no? Next. In the number 2, it says in here, you interchange the position of x and y. So, our x now is equated to what? To y. Interchange. Then plus 3. Next, it says in here, after having now the interchanging of your x and y, that's the time now look for the value of y. The new y, which is this one, so for number 3. Okay? So how is that? In our step number 3, we have now in here, x is equal to, that is the same as 2y plus 3. How do we solve for that one? Meaning, what is that? your x must be deducted with 3. Okay? After that one, you notice that that is equated to what is left at the other side? To y. Diba, 2y. Now, what are we looking? The value of y. So what are you going to do? Divided by 2. So that y will be alone. Okay? Meaning to say, we have now in here, that is the same as, what now? What is left? Y is equal to what? X minus 3 over 2. So what is dy now? In the step number 4, you notice that we have y is equal to x minus 3 over 2. But in here, in the number 4, it says in here, replace, change, substitute the new y, which is this one, new y with f of f raised to negative 1. That indicates that we are talking of the inverse function. So meaning, this one would be, we replace this one would be f raised to negative 1 of x is equal to x minus 3 over 2. And what is this? This is already the inverse function. That is already the inverse function. Again, to get the inverse of the function, we follow this 4 steps. Step number 1, assuming that our function is in here. So, assuming that our function is f of x is equal to 2x plus 3, the very first thing that we will be doing is replace your f of x with what? With y. Why? It is because at one point we have said that f of x is the same as y. So meaning to say that f of x now is replaced with y. That is step number 1. Next step, interchange. Interchange the position of the x and y. And interchange. So in the step number 2, as you can see in step number 1, that is 2x, this is y. Now, that will already be in number 2, 2y. Or x minus 2y, x is equal to 2y plus 3. Next, in the step number 3, that's the time now you are going to solve for the new value of y. So as you can see, in here, that is the same as to solve for the value of new value of y. That is the same as I have in here. Positive 3 is transpose. Now it will give you now x minus 3. Okay, go doon. And of course, that is the same as equated to what is left. What is left? If I transpose that one, that is 2y. So I have now x minus 3 is equal to 2y. But we are looking for the value of new y. So I have to isolate your y by dividing both sides by 2. Okay? Both sides by 2. And so we have now, that is cancelled or divided into 1. And so it will give you now y is equal to x minus 3 over 2. It says in here in the step number 4, meaning to say, we have to identify this one, the result in number 3, to be an inverse. By what? By replacing the value of y, new y, with f raised to negative 1. To indicate that this y is the inverse of the given function. And so we have now this one, the inverse of f of x is equal to x minus 3 over 2. So that is the inverse. Notice that we are going to elaborate this one. Now, in our illustration, to illustrate this one, we will replace this one with the g of x. So our g of x, okay, g of x will be x minus 3 over 2. Minus 3 over 2. Originally, we say f of x is equal f of g of x, f of g of x is the same as g of f of x. Now, but our x will always be the same. Okay, our x in here is the f of x and the g of x. We'll use this one. Okay, so notice that when I will be equating this one, so f of x, what is that? 2x plus 3. Outer function. What is my outer function dito? G of x is x minus 3 over 2. Next, notice that our x in here will be what? G of x. So our x will be g of x. And we will also change the one. Now, notice in here that I already changed my x to g of x. Because that is already changed, you have to change this one. So what will be the result? That is 2 multiplied by g of x. I do not know in the page number 46 kung pareho ang style ng pagsagot. Kaya tingnan nyo, dinidetalyado ko. How about dito? We will also change your x to what? F of x. So it will give you now that is the same as f of x. If I will change this one, I will also change this one. So it will give now that f of x minus 3 over 2. Let's continue. So notice that g of x is the same as x minus 3 over 2. And of course, that is the same as I will change 2 multiplied by, that is x minus 3 over 2 plus 3. How about the other side? Palitan natin. The other side. G of x or f of x, what is our f of x? 2x plus 3. So we have 2x plus 3. When we change this one, we have to change also this one. That is the same as saying now, 2x plus 3, ito, but we have the original minus 3 in the equation, minus 3. Minus 3 over 2. Let's continue. This one will already be what? Okay? This one will already be what? Cancel. What is left? X minus 3 plus 3. How about in here? Notice that 3 minus 3 is what? 0. What is left now? 2x over 2. Notice that when I have this one, negative 3 plus 3, what? 0. What is left? X. Notice in here that if I will divide 2 divided by 2, 1 multiplied by x, that is x. Are they the same? That is the meaning of one-to-one correspondence a while ago that I already mentioned. The value of x corresponds to exactly one value of y. That value of y will never be repeated. One-to-one correspondence.